Okay, this is the last section in this module, and it is the most complicated section in this module, but it's not the hardest, okay? You just need to follow the rules, and it's just as easy as what we've done, okay? You're probably thinking, well, that wasn't easy either, but one step at a time. Every step you can do. It's just the combination of all of them that makes it difficult, okay? So what these look like is you're going to have absolute value with something in between. And then instead of an equals, you're going to have an absolute value symbol somehow equal to a number or something. Okay? So before we had an equal sign here, and now we're going to have any of these, right? Any of the inequalities that we have done in the past. Okay? And that makes it fun. I know, it's different. So to me, it's fun. And this is what they look like. Okay, this page is full of all kinds of things. Okay, so taking one look at it, don't panic, I promise. Okay, so I'm going to zoom in one step at a time. Let's look at these two. Okay, what does absolute value mean? It's the distance from zero, right? Okay, so this part right here means the distance from some number to zero. We don't know what that number is, but it tells us that it's greater than 3. Okay, so think of pod seating back in COVID. Okay, so what that means is let's say you are sitting like right here, and the distance between you and the next person has to be more than 3. So 1, 2, 3, the next person could sit here, but they couldn't be any closer. They could be here or here or here. You just can't be closer because that would violate the rules, right? Okay, so 3 seats in between. They could sit right here. 1, 2, 3, or this way, or this way, right? Okay, so that teal part is this number line here. Okay, so they can't be at 3. That's this part. So they cannot be in the third seat or in the third seat from you, but they can be everything else afterwards. So it's open at 3 and out, okay? Because the distance has to be greater than a certain number. Okay, so that explains this part and this part, and that's it. We'll get back to the others here in just a second. I want to look at the bottom part, the less than, okay? So again, let's look at stadium seating. Okay, but this time, what does it represent? If the absolute value is less than 3, okay, so if the distance from some number, 0, or some number x to 0, let me try that again. The distance from some number to 0, that's what absolute value of x means. This time it needs to be less than 3. Okay, so again, you're sitting right here. Other people could sit here or here, but they could not sit 3 away from you. That would be this one, and that would be off. That's this one, and that is also off. Okay, so it's said to be between 3 and you. 3 away and you, but not including 3. Okay, so let's look over here. That's what this graph means. 0, you are in the middle, and here's people sitting next to you, but they cannot be 3 away. They have to be less than 3 away. Okay? All right, so that covered that and that. Kinda. I'll do them all again, I promise. Okay, so now I'm going to look at this graph. This is the top line, is what the inequality looks like when you solve it. It's going to be an or because it's in two separate parts. Okay, if you remember back when we did it before, we would have had an open circle here, and we would have had an open circle here, and they both drop down onto the number line to give you the answer, right? Okay, and it had to be an or in order to have both parts included. Now the bottom part down here, it's a tripartite, which means it's automatically an and. Okay, we would have had an open circle here going this way, and an open circle here and going this way. Combining them with an and means every place they overlap, which is what you see here. Okay, so and, which is a tripartite every time. You will very seldomly see and written in this type of problem. And I'll show you both ways, but you usually don't. And I'll show you that as well. Okay, so that covered this part and this part. Now we still have interval notation, and that's it. Okay, so you're reading the number line from left to right. You come to the arrow first. That's an infinity, right? This one's the left, so it's negative infinity, and it will be open. Open circle here, so it's a parenthesis, -3. Because it's an or, it will automatically have the union symbol here. And then continue over, open circle at 3, so it's a parenthesis, continues to infinity, parenthesis. Okay, bottom one. We're reading across. First thing we get to is the open circle. Then the other open circle. So -3, +3, open. Okay, now that covers everything on this page. It's still kind of crazy. But let's take a look at individual problems and see how this plays out. Here are the steps. I'm going to go through them as I do a problem with you, and I'll explain this part and this part. Step 2 is just making a decision. That's it, so don't panic on that one. So here we go. Oh, that's my version of this, okay? And also this was from before, just so you can remember. When they call it a conjunction, it is an and, it is this symbol, or it's one equality with three parts, the tripartite. If it's a disjunction, it's an or, it's this simple, and it's two inequalities. So one going this way and one going this way. Okay, this will make more sense when you see a couple. Okay, so here we go. I'm going to cover what they have done and do it with you before you do the one that says your turn. Okay, so looking at the two of these, absolute value with something in it greater than or equal to 6, absolute value with something equal or something in it is greater than 2. Okay, the greater than and equal to and the greater than are treated the same way. Okay, so greater than or equal to's are the same. Less than or equal to are the same. Okay, so with just the equal to is different with the closed circle instead of the open circle like we've already done. Okay, step 1 is always to isolate the absolute value. Okay, in this case, it's already done. So we don't have to do anything on that one. Step 1's done. Step 2 is to rewrite without the absolute value. And the way you do that depends on this symbol. Greater thans are always or statements. Okay, so greater than or equal to, these are both or. Less than or equal to are both and. Okay, so we're doing an or for this one. All right, what it does is like we did an equal sign, we're going to split it into two parts, one to the left, one to the right. But now the symbols are just a little different. Okay, if you remember in the seating, okay, right here, this is the greater than problem. And the distance between you and the next person had to be greater than 3. So this side is greater than, but this side is actually a less than. It points to the left. Okay, so when we write the left side, we're going to drop the absolute value, and we're going to flip the inequality sign so it goes to the left, and we're going to move to the left 6 places. Okay, I'll go over that again, but let me do the whole thing here. Then we're going to put an or because of this sign, because it's greater than or equal to, which is one of these. And then to the right, you're going to drop the absolute value, and it's going to be greater than or equal to a positive 6. Okay, so on the left-hand side, drop the absolute values, flip the inequality, and switch the sign on the 6. Or, because it's one of these two symbols, greater thans are always or, you're going to drop the absolute value, keep the symbol, keep the 6. Okay, now you solve that. And you already know how to do that part because we did those before. Okay, so here's the center, add 2, add 2. We get 2x is less than or equal to negative 4. Divide by 2, divide by 2. I'm not changing anything because that pink 2 isn't negative. Okay, so that stays just how it is. Okay, over here, we're going to do the same steps. Add 2, add 2. 2x is greater than or equal to 8. Divide by 2, and we get x is greater than or equal to 4 with an or in between. Okay, so that is the answer, the inequality answer when it says solve. I just did. Now we have to graph it and write interval notation. Okay, so the graph is going to have a negative 2 and a positive 4. At 2, it's a closed circle and to the left. And at 4, it's a closed circle and to the right. Okay, I did not do any work above because when you're doing absolute value inequalities, a greater than will always look like 2 dots and going out from both. Always. Okay? You don't have to do anything above and figure out how they overlap or everything in both or any of that. It will always be the left dot going to the left and then the right dot will go to the right every time. Okay? And interval notation, negative infinity to positive 2, or negative 2, sorry, parentheses, bracket, and the union symbol, bracket at 4 because it's a closed dot, positive infinity with a parenthesis. Okay, so solve, graph, interval notation. Okay, not too bad once you get that first blue part. All you have to do is make a decision. You look at this, okay, isolate it first, then make a decision. Is it an and or an or? If it's an or, you do this. If it's an and, we'll do that next. Okay, let's do step 3 over here. Solve each part. And keep the or. Okay? And then you do the number line and the other. That's just in the solving part. Okay, do yours. See what you can do with that one. Okay, like I said, the only difference is that you have a greater than instead of greater than or equal to. I'm not going to explain the difference yet. Go ahead and try it. Okay, I'm going to zoom in a little bit, but not too crazy because I want you to see the other problem as we're doing this one. Okay, so it has a greater than, which means it's going to be an or. Because it's an or, we're going to drop the absolute value sign, flip the inequality, change the sign on the 2. Or, drop the absolute value, keep the inequality, keep the sign of the 2. And now we solve each side separately. Okay, so over here, minus 8 minus 8. So 9x is less than negative 10. Divide by 9, divide by 9. X is less than negative 10 ninths. Okay, other side. We're going to minus 8 on both sides. So we get 9x is greater than negative 6. Divide by 9. And we get x is greater than, now you're going to have to simplify this one. Both of these divide by 3. Okay, so we get negative 2 thirds with an or in between. Okay, number 9. How do you tell which one comes first if they're fractions? Okay, this one is an improper fraction. It's negative 1 and something. So that's going to be further down than something that isn't past 1. So this one's going to be first. So here's negative 10 ninths, and here's negative 2 thirds. You could rewrite negative 10 ninths as negative 1 and 1 ninth if that helps you put it on a number line better, but it doesn't matter. Okay, these two are going to have open circles. That's the difference. And because it's an absolute value, this is considered a pod seating type thing where you basically are sitting right in the middle and people go this way, people go this way. Okay? All right, so now how do you write it? Interval notation. I'm going to get rid of that. We start at negative infinity and go to negative 10 ninths. Both of them are open. It's the union of that one and this one, both using parentheses. Okay, I blanked out the work for the one on the left. And now these two look very similar again because absolute value and you have a less than, absolute value and a less than. Okay, on this last page right here, less thans were ands, right? Okay, and previously on this page we said that ands are tripartites. They are the 3-part problems. This is how I'm going to do it because it's much easier, and you'll see. Okay, so here we go. On the left-hand side, I'm going to isolate the absolute value, but it's already done. So now we need to split it into parts. The way you do that with the tripartite is you take this center part, drop the absolute values. It's not really the center. It's going to be the center. Okay, now you leave the less than or equal to 4 right here. But now on the other side, to make it into the tripartite, you're going to use the less than or equal and put put an opposite, -4. So this means the distance from 0 is less than 4. So you've got to start at 4 to the right and 4 to the left, and you want everything in between, right? You want in between those two numbers. So because it's 4 away and it's to the left, we get the negative. Okay. So now solving this one, remember whatever you do to the middle, you have to do to both sides as well. So in the middle, we're solving for x. I want to get rid of the extras, which is the 6. So I add 6. I do that now to the left and the right at the same time. You can't do one on one step and one on another step at the same time. So this side is 2 is less than 3x because the 6's are gone, which is less than or equal to 10. I think I may have said less than instead of less than or equal to right here. Okay, now we're going to divide by the coefficient. So divide, divide, divide. All three parts. These cancel. So we end up with 2/3 is less than or equal to x, which is less than or equal to 10/3. And this is what makes this one so simple, is now when you're doing the absolute value, or try it again, the graph of the absolute value, these two just go straight down. So 2/3 is here, 10/3 is here. You have a closed circle because of the equal to bar, closed circle, and in between. Okay, not very good shading. There we are. Okay, so it just makes it so easy to do a tripartite. Okay, now interval notation. It's a bracket at 2/3 because it's a closed circle, and at 10/3 it's also a bracket. Okay, all right, go ahead and try yours. All right, so drop the absolute values, and that goes in the middle. Less than 2 goes on the right. You put another less than symbol on the left, and you change the sign. On the 2, that is. Okay, so now we're going to add 2 to all three. And we get 0 is less than 8x, which is less than 4. And again, don't freak out with the zeros. Zeros are a number, and it's totally fine. Now we're going to divide all three parts by 8, so that x is left in the middle by itself. We get a 0 here. Simplify this one, and you get 1/2. Number line. The 0 comes straight down. The 1/2 comes straight down. But this time we have open circles. There is no equal to bar on the less than, so you can't fill it in. Well, you can fill in the number line, but just not the endpoints, right? Okay, so open at 0, open at 1/2. Yeah, I like these. Okay, of course you have to have special cases. Okay, let me zoom on these two. All right. Notice that the special case has to do with a negative over here. Stuff inside the absolute values can be anything. When you have one symbol, it acts different than the other symbol. Greater thans have one answer and less thans have another answer. But it's always a special case when it's negative. You probably remember from last section, if I had the absolute value of anything equaled a negative number, we would have said no solution. The difference here is that this represents an infinite number of answers. This is just one. This represents an infinite number of answers. Everything less than negative 3. This is just one. Okay? So you have to look a little bit deeper. All right, I'm going to draw a line here because this is one and this is another. Okay, so the first special case, if it's greater than, right here, this means your distance between something and 0 has to be greater than negative 6. Okay, numbers greater than negative 6. And let's just look at integers. Okay, so greater than or equal to, because it says it can be. All of these numbers are greater than or equal to negative 6. But now look, I'm getting into the positives. Okay, so when it's a greater than, it includes all the positive numbers, and that's okay. Absolute values can be positive. Okay, so when it tells you that the absolute value, once it's isolated, is greater than a negative number, then every single number is correct because all of these numbers are greater than a negative. Every single one of them. You don't even have to solve it. Okay? The bottom one, we want all of these values, absolute value is less than, or the distance from 0, right? We want that distance to be less than negative 3. Okay, so here's negative 3, less than negative 3. The negatives keep getting bigger, and they are never going to turn positive. You're just going to keep getting bigger and bigger until you run out of room, you run out of pencil or whatever. You're just going to get bigger negatives. It will never turn positive. Okay, and because this will never give you positive numbers because it's less than a negative, that's why you get no solution. Because distances have to be positive. Okay, so let's take a look at some actual problems here. Can that all fit on there? That's kind of tiny, but yep, it fits. Okay, here's a problem, for example. You can't tell really whether it's going to be a positive or negative value yet because it's not isolated. So let's do that. Isolating the absolute value. So here's the center. We need to get rid of the extras first. So negative 3 times the absolute value of all of this is greater than 2. Let's get rid of the coefficient. So divide by negative 3. Whoops, divide. There we go. Negative 3's cancel. So now we have isolated the absolute value. Because I divided by a negative, that's going to flip around. And I have a negative 2/3. Don't even need to do anything else. As soon as you get an isolated absolute value with a negative, you can solve it. Okay, this one is no solution because this needs to be positive. It's an absolute value, positive or 0, right? So non-negative, basically. But now it's saying this has to be less than a negative 2/3. And on a number line, here's 0, here's negative 2/3. Everything less than that is still negative. All of these are negatives. So you can't have absolute value of anything less than this. That makes no sense. Okay, here's another one. We need to isolate. So Let's add 8 to both sides. Those are the extras, so those cancel. You have the negative absolute value of 3x add 2 is less than or equal to positive 2. We have to divide by the coefficient. In this case, it's a negative 1, so these cancel. We end up with the absolute value of all of this. Flip the sign around because I divided by a negative is negative 2. Okay, and you're done. All real numbers. Why? Because absolute values need to be positive, basically, other than 0, so positives. Every positive number is greater than any negative number. No matter what I put in here, it will be true. Okay, and then you could put this on a number line and you could do the interval notation. Okay, all right. These next 7 problems are for you to do on your own. Okay, I'm going to do all of them, but try to do all 7 of these first and then come back. Okay, which option is correct? In other words, if this is a less than, is it going to be an or is it going to be a tripartite? And it will be the tripartite every single time. This one is if it were greater than. Okay. Bottom one. Okay, so it's a greater than. We're going to do the left part, which is drop the absolute value, flip the sign, change the sign, or drop the absolute value, keep the sign, whoops, keep the sign, there you go, keep the number. Solve both parts. So minus 10. I'm going to do all of them because I have to change colors. So x is now less than negative 25, or x is now greater than 5. That's my solve. Number line is going to be negative 25, positive 5, open circle to the left, open circle to the right. And interval notation, negative infinity to negative 25, union symbol, 5 to positive infinity. There we go. Hopefully you got it. Let's try the next one. Okay, this one is another greater than. However, it also has a negative. So because it's a negative, it's one of those special cases, and you can stop right here. Every absolute value, because it will be positive or 0, is greater than or equal to negative 5. Everything. Every answer is possible. Okay, so all real numbers is your solve. Graph it is the entire number line. And interval notation is from negative infinity to positive infinity. Okay, let's say you didn't catch that. Okay, this is what you would have gotten. Now look at this. According to what I've told you, this goes here. It's 1.5, and this goes here, negative 1. That doesn't make sense. Okay, you can't have a positive to the left of a negative. This is just impossible. Okay, so that number line isn't able to work. Okay, so let's say instead of that, you put them where they belong. So this one would be closed and less than. This one would be closed and greater than. and it's an or, which means everywhere or everything in both, right? Which would be the entire number line. Okay, so it takes longer to get to it, but you will eventually get to the right answer. Okay? All right, so if you could recognize it's a special case because of this negative, you're done. You don't have to do any of this. Okay, here we go. We have a less than this time. Because it's a less than, it's going to be a tripartite. So 3x minus 1 less than or equal to 7. There's a less than or equal to on the other side with a negative 7 on the left. Add 1 to all three parts to get rid of the extra in the middle. And we get negative 6 less than or equal to 3x, which is less than or equal to 8. Then divide all three parts by 3. 3's cancel in the middle, which is what we wanted. So x is in between both of these. We get a negative 2 on one side and an 8/3 on the other, which is basically 2 and 2/3. Okay, because I'm out of space, I'm going to do it over here. But negative 2 should drop down. 2 and 2/3 will drop down. So negative 2, and I'm just going to leave it 8/3 though. Close circle for both of them. And in between. Those are closed, I promise. Which means bracket 2 8/3 bracket. Okay, next one, number 5. You don't have the absolute value isolated yet. We've got to get rid of this 3. But that negative still should be a flag, right? Okay, I'm going to divide by 3. 3's cancel. We get absolute value of 2x at 1 is less than negative 4, which it can't be. You're done. Okay, again, let's say you don't recognize that. So you write the middle part is the absolute value dropped, less than negative 4 on one side. Other side, you change the signs. This is illegal. You can't write it that way. It can't be done because this number has to be less than both of these numbers, which it isn't. Positive 4 is not less than negative 4. Okay, so can't do it, can't do it. And the last two, here we go. This one is a greater than, so it's going to be or. The one on the left is going to drop the absolute value sign, flip the inequality, change the sign on the 6. The right-hand side is drop the inequality, keep, or drop the absolute values, keep the inequality, keep the 6. Okay, so now we're going to times both sides by 4, get rid of the fraction. 4's cancel. So I get x add 18 less than or equal to negative 24. Okay, here we don't have to worry about the fact that it's a negative because there are no absolute values anymore. We dropped them. So we're just going to keep solving. Okay, so minus 18 minus 18, and we get x is less than or equal to negative 42. Okay, other side is times by 4 times by 4. X is, or x add 18 rather, is greater than 24 minus 18 on both sides. So we get x is greater than or equal to 6. Okay, number 9. We have negative 42 and positive 6. Close circle to the left, close circle, and to the right. Interval notation, negative infinity to negative 42, or 6 to positive infinity. And there we go. And last one. This one we have to isolate the absolute value first. Have to. Okay, so add 3 to both sides. We get 2 times the absolute value is greater than 16. And now we're going to divide by the coefficient. So we get the absolute value of x at 5 is greater than 8. It's not a negative, so we're going to keep going. It's a greater than, which means it's an or. Okay, and I'm going to come up here. So drop the absolute values, flip the sign, change the sign. Drop the absolute values, keep the sign, keep the sign. And now solve both sides separately. So subtract 5, and we get x is less than negative 13, and we're done on that side. Subtract 5 here, and we get x is greater than 3. So we're done on this side. So we solved it. Now here is absolute, or why do I keep doing that? The number line, because it's an absolute value and it's a greater than, your graph will always look like 2 dots and going outside of the 2 dots. You just have to figure out where they were and whether they're open or closed. In this case, they're open, and that goes left of the 13 and right of the 3. Okay, I'm going to slide it up just a little. There we go. And negative infinity to negative 13, open on both, or 3 to positive infinity, open on both. Okay, so they are complicated, but they're not hard. Every step is something that you've done before, basically. You just need to know how to put them together the right way. Okay, hopefully you did really well on these last 7. If not, let me know in class what questions you have, okay? All right, you've got this.